Hey guys, want to learn how to make your very own adjustable stir table? Stay right here and I'll show you how. This is Do-It-Yourself Electronics with me, misperry. What's up guys? Okay, now we're going to go ahead to get into this. We're going to look at how all the pieces that we need, or at least the majority of the pieces that we need, basically your main components. First off, I'm going to scoot this box off to the side so we can actually see it. You're going to need some sort of a, we call these wall warts, but it's basically a power supply. I don't know if you can see this, the light on it. It's basically a 6-volt DC, 300 milliamp. Power supply is what I got. It's got the little barrel connector on it that matches this little barrel connector I had laying around. These are just a DC10A, I think, barrel connector. You can see it just slides onto that. So that's going to be our power connector. Also got a 10 kilo ohm, if you can see that, 10K rheostat or potentiometer, whatever you want to call it. It's just got the three, terminals on it, like a normal potentiometer. Then I went and got a button, and a knob for these, which you can buy at your local Radio Shack, and it just goes on, and then that way you have a nice, neat knob for this. Also, you need 2 neodymium magnets, and I prefer to use the neodymium magnets because they're very, very, very strong. Okay. You'll also need a stir bar, which you can get from any homebrew supplier, or you can get it off of Amazon. I got mine off of Amazon, and all they are is they're just a magnetic bar. See, they stick. They're just a little magnetic bar, and that's what we're going to do. And this one was basically perfect for having two of these magnets side by side, and that's what those are. So you need a stir bar, as well as, excuse me, you need a little motor. Again, this one you can get from Radio Shack. It is, I don't know, about a 9-volt. I think 9-volt max, I think, is what this little guy is. Could be wrong. Could be more. But anyway, get one of these little motors. But however, you also need some sort of a hub to go on the shaft of it. So, excuse me. So what we got is I found a place called robotshop.com. I'll put a link in the description for this, but they have these little hubs. And now I think these are actually really for in the robot shop way of doing things. I think these are for like a wheel. It's like a wheel hub, but this is going to work great. It's aluminum. And so what we will end up doing is we will glue our magnets to it, and see the magnets fit like perfectly on it. And it has a little Allen set, and then it even is built for a 3mm shaft. The 3mm is the one that I got. It's a little big. I don't know if they have one smaller, because this is just barely over 2mm. So, but it's going to work, and it's not going to be too far off balance, because that's the big key with this, is you don't want this thing to be way off balance. Otherwise, it's going to sit, and it's going to shake, and it's going to just throw everything apart. So, but this actually, it's not that bad. It's a little wobbly, but it's not bad at all. I actually have kind of assembled this in kind of a test setup thing with some clamps and whatnot, and it does quite well. So you'll have to pick one of these up. I was going to just make one. I've got some aluminum and stuff, but I figured not everybody has a lathing system. So I better not do that. I figured I'd show you guys a place to pick that up. Then lastly but not least, you need a project enclosure. You can get these at your local Radio Shack. These are actually pretty cool. And they come with a plastic lid that comes off. It comes with screws and whatnot, as well as it comes with a metal lid. And I'll be showing you what we'll be using the metal lid for here a little bit later. So those are your basic components. You'll need some screws, some little screws. I can't remember if they're number 1 or number 2 screws. I'll look it up when we get to that point. But you'll need some little screws so you can mount this little motor into the metal piece that I'm going to be showing you how to make. And that's pretty much it. Some wire, some solder, and let's get into it. All right, I'll be back in a flash. We'll work on the box. We'll go over and probably drill our holes and whatnot, and modify this metal lid for what we need it to and whatnot. So I'll catch you in the garage. Be back in a sec. Okay guys, welcome to the garage. So now we're going to be working on our box. So I got our box here, okay? We're going to be working on this lid, all right? So what we're going to be doing is we're going to use this for our mounting bracket, okay? So let's pop this open and get all this stuff out of it. Ooh, save the screws because you're gonna need them. All right, so we got our box and we have our lid. This lid usually fits inside this box. Well, what I'm going to do is we're going to modify this, like I said, and make this into our way of being able to mount our motor into the inside of the box, because the motor is going to have to sit down inside the box and spin those magnets, and then when we put the plastic lid on top, like so, we can put our big flask on top and drop the little pill thing in it, and then it'll spin. So we want this to be able to be somewhat adjustable also, because that way we can get those magnets right up against the lid of that thing. So that way we can get a good magnetic contact. So first of all, if you notice, there are these little mounting screw holes in here, standoffs in here. And so what we need to do first is I'm going to just take the corners of this off. So a good thing to always have with you, good old-fashioned Sharpie. So what we're going to do is I'm going to mark out and just kind of cut the corners off of this, so that way it will begin to want to slide down inside of this. Because the idea is we'll probably end up making some sort of a, I'll cut the corners off and we'll shave down the sides a little bit, but we want it to where it'll slide into the box, to where it'll actually, we can put it in and it will go down inside of the box. That way we get a height adjustment, okay? So that's the first task. And to do that, like I said, we're just going to take our good old tin snips, which you can get these at any hardware store. They're just like a scissor cutter, but they're built for metal, so they cut metal just like scissors. And this looks pretty thin. I wouldn't say cutting anything. And then I don't know if this is steel. It feels like aluminum, so it should be pretty easy to cut. These cut all different types of steel, but when you get up into the heavier gauge steels, they get to where, you really need some sort of like a bandsaw or something. I don't know if you see that in the background. You need like a bandsaw or something to cut heavier gauge metal. But this stuff, these should be just fine. So we'll see here in a minute. So what I'm going to do is I'm going to go ahead and mark this. Oh, excuse me if I'm making noise with the microphone. I'm resituating it. It's kind of hot out here in my garage. So what I'm going to do is I'm just going to put it into the box somewhat. In fact, what we'll do is what I'm going to do is I'm going to use this other lid as a template. I'm just going to lay it on top of it and just grab me a straight edge. Always have rulers and straight edges with you. That way you can make nice looking cuts. So we're going to mark one. Mark the next one. And like I said, this doesn't have to be perfect. You're never going to see it anyway. So it's going to be on the inside. So if you don't get the lines or the corners, like a perfect triangular cut on them, it doesn't matter. You're not going to see it. So anyway. Okay. So we got our marks, got our corners marked out. So we'll go ahead and pop these bad boys open, and we'll just give ourselves a little snip here. So this comes off quite easy, as you can see. See, it comes off real easy. Cut some more here. Get this other one off. And just go around the bend here. Other one off. So now, be careful with these. These are going to be real sharp, so be careful with them. Make sure and throw them in your little trash pile or in your trash can or something. Make sure it's out of the way. And the same with the edges. These are all going to be sharp. Probably by the end of this, I'll probably hit this on the bench grinder over here, or take take a rasp or a file to the edges of it, make sure it's not so sharp, because these will be sharp. So now, with that done, as we can see, we can get past. Now with that done, we can get past those corner pieces, so we can slide down. But we need to take some off the edges. So what we're going to do is we want this to be a pretty snug fit. So what I'm going to do is I'm going to take my little ruler. I've got one of these little rulers. And I'm going to kind of measure, because what they do inside these boxes, I don't know if any of you have ever seen these, but these enclosures you get from Radio Shack, they have little ribs inside of them. And what that's for is if you're to take a circuit board and you want to put a circuit board this way and slide it into the box, it can slide in. I think these are these are wide enough to hold like an 062 board or something like that. And the board can slide into it. Now, for whatever reason you might want to do that. Depends on the project that you're doing. But for us, we need to dodge those little ribs, because that's going to be just a royal pain. Because see, that's where our lid actually hits on those ribs. Oops, let me show it to you. Ha! Put it on those ribs. So we're going to need to shave this down a little bit. So I'm going to measure, approximately. And like I said, all this is approximate. I mean, it's, get as close as you can. It's not really life or death. I'm going to measure how thick these really are. So it looks like my ruler doesn't go that far. So what I'm going to do is I'm going to make a little mark on the ruler then, as to how far these little puppies come out. Okay. And then what I'm going to do is I'm going to mark it out on our plate. So that way we know how far we need to cut, how much we need to cut off of it. So we're going to do this on all the sides. Okay, all right, we're back. So what I'm going to do, hopefully this angle you can see a little better. I'm going to kind of stand halfway out of the shot, just so you can see me working on this. So anyway, what I've done is I've made some marks on this. So now what I'm going to do is I'm going to use my trusty right angle here, and we're going to kind of try to square this up as much as we can. Good old trusty dusty pencil. Make some alterations to this puppy right fast. So that. Haven't marked these other sides yet, so I need to mark those. Got a ruler, put a mark on it. Get that one. Get the other side. Okay. Same thing. Take our trusty right angle. So actually, we're going to go this way with it. Line these all up. Okay. Next one. Kind of hard because it's such a tiny amount that we're taking off. It's kind of hard to get it all lined up. Little difficult, but not impossible. Okay. So I've got some lines here. I don't know if you can see that. It's glaring really bad, but there's some lines on it and whatnot. So I'm just going to cut it on the lines. So here we go. Make sure I can get this in the shot as best I can. And I'm just going to take my 10 snips here. We're just going to snip off that little edge. It's going to curl up on us, which is fine. Just let it. Okay. So that one. And like I said, I'll probably go over this with a file once it's all over with to clean it all up, make it look somewhat presentable. Like I said, it's going on the inside of the box, so I'm not real super concerned. But just for looks are concerned, make sure that it's looks somewhat presentable. Form, fit, and function. All right. So there we go. Like I said, be very careful with this stuff because dealing with sheet metal, you can cut yourself. Boy, you can cut yourself. You can cut yourself real bad. So be careful with when you're doing the sheet metal work. I've cut myself more than once doing sheet metal work, picking up filings or getting cut on the edges. So Be careful with that. So now, kind of like I said, it kind of gives it kind of like a warped edge, but yeah, good enough. So, see if it'll go inside now. Ah, perfect. That's exactly what we wanted. All right. So now what we got to do is we're going to need to make, now that it fits inside the box, let's see if I can show you this. So now that it fits inside the box without too much of a problem, now is when we're going to take it, more or less. Now is when we need to take, and we need to make some sort of a way of mounting this in here. So what we're going to do is we'll probably end up using, there's some standoff holes in the bottom. I don't know if you can see that. Let's see if I can get the light to shine in there. There's some little mounting holes in the bottom where you can mount like a PCB or something. My idea was, if I can, is to somehow use those. See, like that, I can't get it to push. I can't get it to go like all the way flush, so I may take a little bit off the edges. But I was thinking of using those in some form or fashion, some way or something, to clip that in there. Of course, it's kind of fitting snug anyway. The nice thing about these boxes is, I don't know if you can tell, but if you look at the end of it, it's actually wider at the top than it is at the bottom. It actually is on an angle. It's actually, the box, instead of being perfectly straight, it's actually kind of cantilevered like that. So it will necessarily, if you measure the top of it, it'll get tighter as you push it down in there because the box slides in. So what we're going to do is I'm going to go ahead and I'm going to get some other materials, other tools, and we're going to work on that next. So stay tuned. Okay, guys. All right. I found, got some all thread rod here. So, woohoo. So what I'm going to do, you can use any size. I really don't even know what size this is. I'll have to go figure it out. I don't know. This looks like maybe, number 10, 1024 maybe, or something like that. Maybe a little bigger. This might actually, it's probably even 1/4 inch. I don't know. It's a fairly good size. Probably any size will do. This is just all thread, so the whole thing is threaded. What I'm thinking about doing is we'll take this and we'll end up planting it inside our box. I'll cut little pieces and then we'll drill holes in our plate here in like, I don't know, the 4 corners or something. And we'll plant these in here and then we'll be able to screw 2 nuts on. One will be on the bottom and one will be on the top. And then that way we can actually adjust the level of this. And so that's what I think we're gonna end up doing. So let's get to cutting some all thread and we'll drill some holes in this. So off we go. Now, when you cut all thread, I'm just using, they do make special cutters and whatnot for it. I'm just gonna do it the old fashioned way and just use a pair of side cutters is what these are called, or clines. If you work in the electrical trade, you know these as being clines. But anyway, when you cut it off, I don't know if I can show you this. Cut it off, you get this weird burr. I don't know if it's gonna, see if it'll focus on that. You see that? See that weird little burr that's there, that's on the end of it? That will mess up the ability to actually get a nut started on it. So that's where the file comes in handy. So if you have, of course I'll be cutting this off so I won't be like this, but if you have a vise or something, put this in the vise and then you just have to just file that. Well, it's going to be hard to do holding it. Really need to put it in a vise. But you basically file that off. And you file it around, and you spin it, and you file around the corners, and file that off. And then what will happen, in fact, actually, that's pretty good. It doesn't take a whole lot. I mean, it just takes a little bit. If you get a real good coarse file, it doesn't take very long. And you just kind of twirl it around and just clean up that thread. Look at it and see where it might be, smushed over or something like that. See now, I don't know if you can see it now. Now, that's a little bit better. It's getting there. Maybe that side needs a little more touch-up work, but it's getting better. See, and then that way when you put your nuts on, it'll go on a lot easier. See, so just kind of hit that one side again, hit the top of it a little bit. Yeah, that's looking pretty good. So anyway. So that's what I do in a pinch. You can buy special tools that this like screws into, and then you cut it. It's like a hand tool, but it like when you put this in it, it actually like screws into the tool, and then you cut it in two, and that way it keeps the threads. But if you don't have those tools, those fancy tools, Barracklines works pretty good. A pair of wire cutters, those other kinds, nipper wire cutters, whatever you want to call them, they work well too. They're a little tougher to cut with that, so since it is steel, so it is hard to cut through. The side cutters work the best. So we're going to go ahead and I'm going to look at how high I want to make this, because remember I got to have little nuts and stuff on it. So I'm going to say, my trusty dusty ruler here, I am going to say probably about 2.5 inches. I think will be fine for this guy. Make sure I get a good clean end. So probably about 2.5 inches ought to be about perfect for us. So I'm going to lay this down and I'm going to mark out some 2.5 inch pieces here. So we got 2.5, and get out the good old marker. There's 2.5. Go from there. 2.5. There. One more. Okay. So I've got me some marks down through here. So I'm just going to cut each one of these off. Now make sure, remember, pay attention to which way you marked it, because that's going to matter when you cut it, because you don't want to be off. So I'm just going to cut one. And we'll get over here. Second one. 2. 3. Last one. I tell you what, it's good to have a good pair of clines or side cutters, whatever they're called, that have good handles on them, because if you have good handles on them, then it won't hurt your hands so much. All right. Well, I got my pieces cut, so there they are. Got my pieces cut. I'm going to clean these up with the file, and then we'll be right back. Okay, guys, tell you what we're going to do now is we're going to go ahead and we're going to drill some holes. I went ahead and marked up some holes on there, even our center hole. We're going to drill some holes in this. So how we're going to do this is, first off, we need to know how big of holes we're going to drill. Now, I've got one of these sets of vernier calipers is what they're called, or we just call them calipers for short. You can pick these up pretty cheaply on eBay or anywhere, but these help immensely if you're wanting a snug fit or something to help you choose drill bits. So what we're going to do is we're going to measure our little guys. So they're about 3 point. Of course, I like doing everything in inches. Yes, I know. I'm from the United States. We always do everything in the standard units or whatever, and it's all crazy and weird. And we do it because, I don't know, I guess maybe because we want to be different. I have no idea. Anyway, since all my drill bits are basically standard, I got to make sure and do everything in standard. So we're about 0.184, so it's a little bit bigger than an 1/8 inch. So let's go with 1/8 inch. Let's do the, I don't know, 5/32. So that'll probably be all right. So that's a 1/5. Let's see where we at. We have 182. Well, that one's not going to work. Let's try the 11/64s. Let's see what that is. Yeah, we're getting closer. Yeah, I'll try another one. Let's try a 3/16. That's a 187. That could be real snug, so we might have to go just a shade bigger. Well, that's 183 and this is 187, so that's probably going to work. What I'm doing here is I'm taking my drill bits and I'm just, here, calipering them. Now you got to be careful on like drill bits like these. I don't know if you can see this. Put my hand up. But if you notice, it's got flat spots on it so that the drill chuck can grab a hold of it. that will throw off your reading. You want to be down here on this end where it's round and it's all the way around, so you get an accurate measurement when you put it in your caliper. And that's reading the, well, stupid glare, 182, 183. Well, I'm not doing it. Trying to do that and hold it up for the camera was interesting. So anyway, this will probably get us our 4 holes on the side. So that's for that. We'll have to measure our motor, but first I'm just going to punch a hole in it. I know that, in fact, I'll just do it with this drill bit. It's kind of like a pilot hole. I'll punch a hole in it first, and then we'll take our good old calipers and we'll go measure the motor, because there's that little kind of like bump that's on the motor, and we'll measure that and drill the hole out. So anyway, so that's what we're going to do. I'm going to come over here with my trusty drill. We'll probably set this puppy up. Get the chuck out here. I've had it set up. I was drilling PCBs the other day. Back at my PCB drills. And we'll chuck this guy in. We may have to lower the table here. But we'll just drill ourselves some plate real fast. So we'll lower this down a little bit. Lock that in. Our plate. Now, the thing you got to be careful with these plates and stuff is you always use some sort of a clamping device, because these plates and whatnot, they like to dance around. Grab a big clamp here. They like to dance around, so you definitely want to take and somewhat clamp them in place once you get them where you're going to drill, because it may want to spin on you, and trust me, it will, especially with all these rough edges that's on this, it will slice your hands up. So I also highly recommend get a pair of work gloves. These things are great. I buy them at my local, well, you can get them at the local hardware store, but these specific ones I get from my local, I want to say mechanic shop, automotive store, so automotive parts store. So that's where I get mine. So that way I can hold on to it. It won't be too terribly bad. Oh my good heavens. I just noticed something. This drill bit is massively bent. I don't know if you guys see that from there. I don't know if you guys can see that from there. It's just, it's wobbling everywhere. I've got a spare. I'll have to get a different one. Well, tell you what, instead of you guys watching me fiddle with drill bits and whatnot, I'll just stop the video right here and we'll come back when I get that all drilled out. All right? So, be back in a second, guys. Okay, guys, we back onto the bench again. I've pretty much assembled everything. I've got our all thread. Just put a nut on either side, essentially. Put a nut on either side. See, and then what I'm going to do is, since I'm just going to attach, what I'm going to do is I just put these down like this, just kind of at the bottom, just so they're flush, more or less. That's what I did. So it gives it some feet. And then I've also installed the motor. I drilled 2 holes for the little guys. That was 2 holes that I messed up on. Good thing about it being a circle is if you mess up the holes, you can always just turn it and drill 2 more. So that's what I did. Then I installed our hub. And how we're going to attach all this stuff is with the good old wonderful hot snot gun, or hot glue gun, or however you want to call it. It's one of the most versatile tools. It works quite well. So what I'm going to do, give you the rundown on how we're going to do this. I'm going to apply some hot glue to all 4 feet, okay? And then I'm going to also take our neodymium magnets and I'm going to hot glue them to the hub, okay? So that should take, now you could, if you're afraid the hot glue might let go on the hub, you could use super glue or whatever, but hot glue I'm assuming will probably be alright, but you know, if I experience problems later on, I may super glue it on. So anyway, so that's what that's going to look like. First of all though, I think I'm going to attach me some wires to the motor. Then what I'm going to do is I'll put a drop of hot glue on each one of these little pegs, and I've already pre-measured this. Take our box and played around with it, shoved it in there, pushed it all the way down, and got it in there. And what I've noticed is I take the lid, I take my 2 neodymium magnets, and since there's a metal shaft in there, they kind of stick So what I've done is I take this and I set it on there just to make sure that it's not totally hitting. And if I need to, I can adjust things. See, like right now it's kind of hitting, so I may adjust those down to where it won't hit. But that's what I basically do. See, take that lid like that. Let me turn the, kind of see it. See, and I run the lid like this to check my clearances. So I'm going to perform a few more little tweaks. Looks like this end's a little high. I need to kind of move that down a little bit. A few more tweaks, and then I'm going to hot glue it in place, at least those little arms. Put some wires on for the, put some wires on, and we should be good to go. Like I said, now that I think about it, I may not hot glue. This is fitting pretty snugly in here. I don't think it's going to fly away. So I may not actually hot glue these down, but I may put little dabs of hot glue here just to keep these from spinning around, you know, so that they'll stay put. Anyway, when I get that over, we'll pause here. When I get that all put together, we'll come back. So give me just a minute, and we'll be back in a second. Okay, guys, we're back. I've gone ahead and put the wires on our motor, our little motor. So I've got some wires on that, as well as I did have to notch, excuse me, I did have to notch a piece because when I drilled the hole and mounted the rheostat, all I did was I just drilled, I think it was, I can remember, it was like 5/16 hole or something like that, and mounted the rheostat so we could have our knob. I had to notch it because the way our stuff was, it had to miss it. So as you can see, that had to miss it. As well as I mounted the DC electric. I just hot glued it. Whoops, see if you can see that. Hot glued it in place is all I did. What I did to steady it while it was gluing was I just took the barrel connector and plugged it into it. So that way it would just hold on to it. So anyway, that's what I did to hold that in place while I glued it. And so that's about it. Then soldered a couple wires on it because this is going to be our power and ground for everything. In fact, I'm going to go ahead and splice these. But there's power and ground. So let's go ahead and somewhat assemble this little guy. So we're going to go ahead and put this in. This good, nice, snug fit. And clearances are good, if I remember right. Yeah, clearances are good. And then if I take, let's see if I have it with me, the flask or whatever, seems to latch onto it just fine. Oh, whoops, sorry, my hand was in the way. It seems to latch onto it just fine. So that looks good. So now, time to wire this puppy up. And I think what I'm going to do is I'm just going to go ahead and wire it up because it's going to be kind of an interesting process because I'm not going to use a circuit board. And you guys can just see what it looks like when it's finished. I'm just going to wire it up. I'm going to post the schematic up in the meantime. So watch this splash of the schematic and I will return when this is all started up and done. Okay, guys, we got the circuit done. I'm going to go ahead and zoom in on it. Hopefully you had a chance to look at that schematic a little bit. But there's our circuit. Essentially, I soldered, there's the jumper for the rheostat here. And then there's our resistor, that one resistor, the feedback resistor. This one's our adjustment, obviously. And then we got our two caps from the input and the output to the ground wire, and yeah, there's pretty much our circuit. Oops, wrong way. So if we want to maiden voyage this thing, I think I've got the let's see. Okay, yeah, I've got the good old power connector. Let's make sure she works. All right, now I would suggest going ahead and putting in a on-off switch. I think I probably will. I've got one over here, like something like one of these. These would be very easy to install. I actually took this out of another project. But basically, if you cut a notch in this side panel, you could stick it right there, you know, and slide it down in. And then that way, when you put the cover on, you know, you've got a nice little on-off switch. So anyway, that's just something else. But as you can see, as we turn the up and down. Now the rheostat that I got, or the variable resistor, it has basically a low cutoff protection in it. It's got basically, when you turn it all the way to the low extreme, it'll only go as low as 2 ohms. It won't go clear to like milliohms, because some of them will go clear down to milliohms, and sometimes you can short out things. Now with this type of regulator, an LM317, if you take the adjustment and send it to 0, it just zeroes the output, is all it does, and it actually doesn't hurt anything. So it just zeroes it. But I may put a little switch in there to allow it to do its thing. Alright, so we know the circuit works. Well, I went ahead, while I had the video off, I went ahead and took the liberty of setting the height of it. Now, this is the great thing. If you set all your settings and everything with the hub all the way against the motor, then you have the entire shaft of the motor that you can move this hub up and down to get it as close to the top of your plastic lid as you possibly can without going over. Now, one thing you have to be careful of is plastic does flex. So when you get a real heavy container sitting on here, let's say, because if it's full of water, it's going to deform, it's going to push down on this. So you want to take that into consideration. What I did just now was I filled up that big Erlenmeyer flask that I had with water, like all the way to the top, even though that's way more than you need to do a yeast starter. Still, you put it all the way to the top. That way it's like worst case analysis, right? And put it on there and see what kind of adjustments you have to make. What I did was I actually went crazy with the whole thing. I wanted to get crazy precise, and I used a feeler gauge. I don't know if any of you have ever seen this, but I used a feeler gauge. And what a feeler gauge is it is a tool that you can use that basically will give you different thousandths of an inch. See, it comes in different thousandths of an inch. Oh, hang on guys, my battery's dying. I gotta plug in real quick. Oh, don't shut off. There we go. I think I got it. Sorry, the camera's gonna kind of jiggle while I get this cord situation kind of figured out here. There we go. Sorry for the jiggliness. Okay, there. Now the battery won't die on us. Anyway, what a feeler gauge is it's a series. I don't know if you can see those numbers on it. These are old. But they basically go up by thousandths of an inch. There's 0.19, there's 0.20, that'll be 0.21, see that? 22, 23, and so on and so forth. So they get thicker by thousandths of an inch. Well, you can also stack them, and then you get, you get different thicknesses. Well, that's what I did, is I just stacked these and would put them in there and push down on it, set them inside and slide it in there, and then push down on it and tighten it down, and then put the lid on, put the flask on top of it, and see what happens. And then, if it was, I went up one by one till I got to where till it hit the lid. It just did hit the lid, and I can hear it, scratching against it with the flask sitting on top of it. And then I just backed it off by one. I just took the last one out and put it in. And so that's what I did. I don't know if you want to go that overboard with it, but that's what I did. So we can now, it's all basically. So we can put the lid on this puppy, and we'll try it out. So let's go ahead and put our lid on. We've got our 4 little screws that it came with. So we'll go ahead and we'll put those in for the first time. Oops, sorry, hands totally in the way. It's hard to, you have to excuse me. Sometimes I'm watching what I'm doing and I'm not looking through the viewfinder on the camera, so I don't see that you guys can't see what I'm doing. So you have to excuse me when I do stuff like that. It is not intentional. It is not intentional whatsoever. See, I'm doing it again. Dadgummit. Not intentional. I'm just trying to pay attention to what I'm doing, not cross thread a screw or something. Of course, with these, it's nice. You can't really cross thread a screw, just because they're just screwing into plastic, so they're kind of cutting their own threads. So if you screw it in sideways, it's just gonna be sideways. That's all there is to it. So there we go. What a snazzy looking unit. You get some stickers and put stickers on this thing. So the moment we've all been waiting for. Let's plug it in and see how it goes, shall we? Let me stop the camera and I'll reset up the camera to where it's at a better angle instead of being straight down on it, and we'll check this thing out. Okay guys, here we are back. Got it all pretty much set up for you. I'm trying to look kind of like sideways through the cap. I guess we'll turn it like this so you can see the dealie. Okay, so let's go ahead and we'll give this thing a shot. Let's go ahead and plug her on in here. Find a little spot. And off she goes. Now, I've heard that there's all kinds of different sizes of these bars. I may go with a bigger one because it looks like this guy, when you crank it up pretty high, or really not very high at all, when you crank it up, it has a tendency to knock it off the magnet. So I may need a bigger stir bar that's a little more beefy that, you know, can't be shoved around. But basically, we can turn it up. I'm starting to kind of get a little bit of a vortex here. So if I kind of crank it up a little more, it starts to, those bubbles are the vortex. As you can see it, it's trying. See if we can get it without knocking it off. There we go. It's doing it. Okay. I don't know if you can hear it, but it makes all kinds of noise when it's doing this. But there we go. And we even got a little vortex going on. So, pretty cool deal. So it does work. It works really well, actually. Now, of course, I haven't added anything to it. Like I said, the stir bar may need to be more. Just depends. Depends on what your application is, what you're going to use it for. You may have to choose a different stir bar based on performance, essentially, because it may not stick in it. And the good thing about having hot glued those magnets in place, you know, you can always take that hub off and pop those magnets off. You just got to pull fairly hard, you know, get a pair of pliers or something, kind of yank on it, and pop those magnets off and change the magnets. You go with a bigger neodymium magnet and get that to work, you know. Just however you want to do it, but it is speed controlled. As you saw, we sped it up to where now we got a pretty good looking vortex going there. And yeah, so guys, I know this video has been quite a journey, but that's how you make your own adjustable speed stir table using electronics, some little simple electronics, LM317 resistor and some wire and a 10K potentiometer and some caps. And basically taking one of these Radio Shack off-the-shelf boxes and using what they give you, which is using the metal lid and other things, adding a few more nuts and bolts and some hardware to it. And there you go. There you have it. You have your own stir table. So, guys, hope you enjoyed this. I know I have. This has been actually a really fun build. This will definitely go up on Instructables. I'll definitely tweet about this guy. I'll probably send some pictures when I do my first yeast starter with this thing. I'll take pictures of it and we'll post that on Twitter. So again, if you haven't subscribed to me on Twitter, I suggest that you do, because that way you can catch those funny pictures and fun stuff that I post, as well as if there's going to be any late videos or anything like that, I will post that information right on Twitter. So that way you guys can stay up on when I'm not available or what's going on. I try to do that because it's a lot faster than making a video and editing it and creating all the stuff and getting it out there just to tell you guys what's going on. It's actually become a lot easier just to do it over Twitter. So anyway, guys, like, subscribe, share, comment. Have any questions or any concerns or whatever, please leave comments. I enjoy reading every single comment that you guys leave. It's been fantastic. Keep coding, keep building fun stuff, because that's what it's all about, guys. It's the fun of electronics. So guys, until we meet again next time in our next video, I think that ought to do it. Take care, guys. We'll see you next time.